By induction, that for all positive integers n, this expression is divisible by 17. So let's start with n equals 1. Then f1 will equal 2 to the power of 4 plus 3 times 5 to the power of 3. Well, that is 16 plus 3 times 125, that's 375, which ends up being 391, which, if you just divide by 17 in your calculator, you'll get 23. So it's 17 times 23. Okay, this is true. Now we're going to assume true for n equals k. I normally ignore the fn at this point, and I can just say, using my assumption, that 2 to the 3k plus 1 plus 3 times 5 to the 2k plus 1 is going to equal some multiple of 17, so 17m, for m being a positive integer. I could say it as a natural number. Okay, now show that's therefore true for n equals k plus 1. We must show that the n equals k plus 1 result follows from the n equals k result. So f of, I will bring this in, f of k plus 1 is going to equal 2 to the 3 k plus 1 plus 1 plus 3 times 5 to the 2 k plus 1 plus 1. This becomes 2 to the 3k plus 3 plus 1. Actually, let me write it as 3k plus 1 plus 3, because I'm going to be dealing with that in a minute. Plus 3 times 5 to the 2. Oh, see, I want 2k plus 1, but then I've got an extra 2. Okay, time to bring these down. I can just go straight for it and write this as 8, because it's 2 to the 3k plus 1 times 2 to the 3. So that's just 8 lots of 2 to the 3k plus 1 plus 25 lots of 3 times 5 to the 2k plus 1 for similar reasons. Now let's factorize out the 8 lots of each. So it would be 8 lots of 2 to the 3k plus 1 plus 3, 5 to the 2k plus 1. And the reason I've done this is that I know that that inside the bracket is a multiple of 17. But of course I'm left with, what is it, 25 minus 8, 17 lots of 3 times 5 to the 2k plus 1. So this thing here is equal to 17m. But check it out, I've got a 17 here, a 17 here. I can factorize out 17. 17 times 8m plus 3 times 5 to the 2k plus 1, which is divisible by 17. So therefore, n equals k plus 1 true. So what we've shown is that kind of the first domino falls over, that's our n equals 1. And then later on, if the n equals k domino falls over somewhere along the domino rally, then it will cause the n equals k plus 1 domino to fall over. But then that means they all fall over, because the n equals 1 domino causes the n equals 2 domino to fall over, which causes the n equals 3 domino to fall over. They all fall over. Our result is valid for all positive integers n. We just write a little conclusion. So n equals 1 true, or you could say f of 1 true. N equals k true implies n equals k plus 1 true. That's the idea. So by the principle of mathematical induction, f of n, and I'm just bringing that back in right at the end, is true for all positive integers n.